Okay, so the first thing I noticed, there's a GCF of 3x. I factor that out. That leaves me with x squared minus 9. Then x squared minus 9 is a difference of perfect squares. So that factors as x plus 3 times x minus 3. Okay, so look at this one. There is no GCF. I notice there's 3 terms, so it's a trinomial. So I do a times c, which is 16. 1 and 16 doesn't work. 2 and 8 does. Okay. So I'm going to rewrite negative 6y as minus 8. It's not y, w. Minus 8w plus 2w minus 16. Group the first 2 and the last 2. The GCF of the first 2 is w. I'm left with w minus 8. GCF of the last 2 is 2. I'm left with w minus 8. So it factors to be w plus 2 times w minus 8. Okay, so here on 3, I'm going to rearrange this first of all to get my variable to the power written first. So that's written as t to the third plus 27. Now they're not both perfect squares, but they are both perfect cubes. And they're being added, so I'm going to use the sum of cube formulas. All right, first I'm going to identify my a and my b. The a is t, the b is 3. Remember, we find those by taking a cube root of the first term and the last term. Now plugging into the formula, this is a plus b times a squared plus ab, minus ab plus b squared, which is 9. Okay, so here's number 4. Now we get that weird parentheses that's being squared at the beginning. So we've been treating that as a perfect square. We also know 9 is a perfect square and they're being subtracted. So it's a difference of perfect squares. Okay, so it's the square root of the first term, which is going to be x minus 2. It's the square root of the last term, which is 3. And then I alternate the signs between them. One's positive, one's negative. Okay, so we start with a GCF here of these two terms. I see very quickly that they both share a 6 in common, and they both have an x to a power. So remember, we talked about all those different ways you could rewrite it, or some of you may can just see it. But if I get an x to the 2c and an x to the c, they share an x to the c in common. And that leaves us with an x to the c in the first one, and a 2 in the last one. Okay, first I look, is there a GCF? There is not. There are 4 terms, so I'm automatically going to try grouping. So I'm going to group the first 2 terms and the last 2 terms. Very good. The first 2 have an x to the 4th in common. That leaves us with x squared minus 2. But the last 2 have a GCF of negative 8. That leaves us with...
Would it be x squared, or would it be positive 8?
Okay, I could factor out a positive 8, but if I did, it would be negative x squared plus 2. The signs would be backwards. So for grouping to work, the parentheses must match. Yep. So this leaves me with x to the 4th minus 8 times x squared minus 2. Okay, now both of those kind of look like they could be factored again, because this is a perfect square, but 8 isn't, right? I mean, I could treat it as square root of 8 if I needed to. but we're not going to. And then this one is x squared and just a 2. So that actually is as simplified as that'll get. Okay, so first I'm looking for GCF. Well, that first term is really ugly because it's a fraction. So I don't really have a GCF that'll work right off the bat. But then I start noticing all of my numbers are perfect squares. And then my powers are x to the 4th and a y to the 6th. So everything's a perfect square and they're being subtracted. So it's a difference of perfect squares. So I get 2 parentheses. I do the square root of the first, which is 11 over 8 x squared. 11 over 8 x squared. The square root of the second, which is 14y cubed. And then we alternate the signs. One positive, one negative. Okay, so this is one that's kind of interesting. There's a couple of different ways you could go with this problem. First, is their GCF? No. Okay, then they're being subtracted. Are they both perfect squares? Yes. Are they both perfect cubes? Yes. So you could treat that as a difference of squares or a difference of cubes. And your answer will look slightly different depending on which one you choose. So first, let's do this as a difference of squares first. Okay? So if I treat this as a difference of squares, I'm going to get z to the 6th plus 8 times z to the 6th minus 8. Now, the first is a perfect cube, and the second's a perfect cube. One's a sum, one's a difference. Okay? So for the first one, the first set of parentheses, a is going to be equal to z to the second, and b is going to be equal to 2. Okay, so that gives me a plus b. Where'd I get what? It's the cube root of 8. I'm still not finished treating it as a difference of squares. So if I go difference of squares first, then I gotta go difference of cubes right after it. And then I'll show you what happens if you go difference of cubes first, what happens. Anyways.
So when you said you was going to difference of cubes, I thought you meant you was
I get you. So this is a squared. So z squared squared is z to the 4th minus ab. So that's 2z squared plus b squared is 4. Okay, then over here, my difference of perfect cubes, again, the a is z squared, the b is 2. So this one's going to give z squared minus 2, z to the 4th plus 2z squared plus 4. So again, remember the only difference between the two formulas is where the negative goes. And since my a and b were the same, I just copied the other one and changed where the sign went. Now this is as simplified as that gets, which means this here would be my final answer. Okay? But now what if I would have first noticed that this was a difference of perfect cubes? Okay, if you went that route, then your a is z to the 4th, your b is 4. Yeah. Okay? And then using the difference of cubes formula, that gives us a, so it's z to the 4th, minus b times a squared plus ab plus b squared. Then we would have to notice our first parenthesis. Those are both perfect squares. That's the difference of perfect squares. So that factors to be, z squared plus 2 times z squared minus 2. And I'm going to bring down the second parentheses. That's z to the 8th plus 4z to the 4th plus 16. Okay, so here I look, is there a GCF? No. There are 3 terms, so I've got a trinomial. So I'm going to do a times c. That's 30. Yeah, again, if you see it that quickly, that's great. What are my factors of 30? 1 and 30, 2 and 15. And 2 and 15 can be used to rewrite negative 17. So that is 10x squared minus 15x minus 2x. Then I'm bringing down the plus 3. Okay, now I'm going to group my first 2 terms together and my last 2 terms together. The first 2 have a GCF of, that leaves me with 2x minus 3. All right, the last 2, the GCF is negative 1 because I need to make sure I get my signs correct. So I factor out that negative 1. That leaves me with positive 2x and a negative 3. All right, and then regrouping this, that's 5x minus 1 times 2x minus 3. Okay, so I got 2 terms. There is no GCF. Okay, but I notice they're being subtracted and they both are even powers. So I have the difference of perfect squares. So this factors to be x squared plus z squared times x squared minus z squared. Okay, now what do we see?
Those are both perfect.
They're both perfect squares again. Now, the first one, they're being added. So I don't have a sum of perfect squares. But I do have another difference of perfect squares. So I need to factor that again. So bringing the first parentheses down, that gives me x squared plus z squared. And then I'm going to treat the second one as a difference of perfect squares. So that's x plus z times x minus z. Okay, so I have this funny looking r, right, that they both share. So I know that's a GCF to start with, so I'm going to factor that out. And then I heard some of you talking. They both have a z to a power. So what's the least one that they, or sorry, what's the greatest one that they have in common?
C plus 1.
They both have a c and they both have a plus 1. So we can factor out z to the c plus 1. Okay, now what's left?
Just Z to
The first one, there's a z to the c still left. Very good. And then the second one, I factored every bit of that out. So there's a 1 left to hold the place. And that's factored. Okay, so first thing I'm looking, is there a GCF? There's not. All right, there's 2 terms, they're being subtracted. 36 and 49 are both perfect squares.
They're perfect.
And then a to the 14p and b to the 6q can also be treated as perfect squares. So I'm going to factor this as a difference of perfect squares. All right, so let's do the square root of the first. That's going to give us 6a to the 7p. 6a to the 7p. And the square root of 49b 6q is 7b to the 3q. 7b to the 3q. And I'm going to alternate the signs between them. One's positive, one is negative. Okay, first thing I'm going to do is I'm going to rearrange this to get my highest power listed first. So that gives me x to the third minus 225x. And I see they both have an x in common, so I have a GCF of x. I factor that out, that leaves me with x squared minus 225. So now in parentheses I have two terms. X squared is a perfect square, 225 is a perfect square. They're being subtracted. So that's the difference of perfect squares. So I'm going to bring down my x that's out front. And then I'm going to factor. So this should give me x plus 15 times x minus 15. Okay, so here again, I could treat this as a difference of perfect squares or a difference of perfect cubes. They both are valid. So I'm going to go with a difference of perfect squares first. When I do that, I'm going to get a to the 6th plus b to the 3rd times a to the 6th minus b to the 3rd. Now then the first parentheses is a sum of perfect cubes. The second parentheses is a difference of perfect cubes. So I'm going to factor again. So the first one, my a term is going to be a squared. And my b term is going to be b. And that's a little funny. The a is a squared. But think back to your formula. You're just going to plug in a squared everywhere there was an a. Okay, so when I do that, that gives me a plus b times a squared. So that's a squared squared, which is a to the 4th, minus ab. So that's a squared b plus b squared, which is b squared. Okay, and now then, since I have the same terms in the second set of parentheses, the only difference is they're being subtracted, then I'm just going to move where the negative is because of the formula. So that's going to be a squared minus b times a to the 4th plus a squared b plus b squared. So you notice how everything else is the same in the formula. And if you chose to do a difference of squares first, it would look a little differently. I'm sorry, if you chose to do a difference of cubes first, your answer would look a little differently. But I'm just going to show that one for time's sake. Okay, so I'm looking here. There is no GCF. It's a trinomial with an x squared and y squared on the ends and xy to the first in the middle. So I just do a times c. 2 times 6 is 12. Okay, what multiplies to be 12? Added or subtracted is 1. Could be 1 and 12. Could be 2 and 6. Could be 3 and 4. 3 and 4 work. Okay, so now I'm going to rewrite that middle term to be positive 4xy minus 3xy. I bring down the 2x squared minus 6y squared. Now I got 4 terms. I'm going to factor by grouping, so I group the first 2 terms together, the last 2 terms.
You're not paying attention to him.
First 2, the GCF of 2x, that leaves me with x plus 2y. GCF of the last 2 is negative 3y. I'm left with x plus 2y. Now my parentheses match, which means the grouping worked. That leaves me with 2x minus 3y times x plus 2y.
He said he like.
Okay, look in here. I asked myself, is there GCF? No, there's not a GCF. So there's 4 terms. I could try to factor by grouping. Okay, but what's going to be the problem when I group? Well, let's just look and see. GCF for the first 2 is x. That leaves me with x plus 6. GCF of the last 2, there isn't one. That leaves me with negative y squared plus 9. So my parentheses do not match, so grouping will not work. So what else have we seen with 4 terms that we could factor? Remember, we had those perfect square trinomials that will reduce to give me a difference of perfect squares. So what I can do is I can rearrange this. I can get all of my terms that have that x. So I've got an x squared plus 6x plus 9. And then what's left is that minus y squared. And we group those first 3 together as a perfect square trinomial. So that factors to be x plus 3 times x plus 3, which we can write as x plus 3 squared. If you need to do the a times c method, you can. All right, but I'm not going to here. And then I bring down the minus y squared. Now I have the difference of perfect squares. So the square root of the first is x plus 3. And x plus 3. The square root of the second is y and y. And we alternate the signs. If you're looking here at number 18, first thing I'm going to look for, is there GCF? There is. They both share an x and a y, so I'm going to factor that out. When I do that, that leaves me with x squared minus 25y squared. Now what's in parentheses, they're both perfect squares and they're being subtracted, so that is the difference of perfect squares. So I can write that as the square root of the first, the square root of the second, and we alternate the signs. And that's the factored form for number 18. Okay, here on number 19, I'm first looking for GCF. I have one. They share a 15, and they all have a t. So I factor that out. That's going to leave me with t squared minus 4t. And then 315 divided by 15 is 21. That's minus 21. Okay, then in my parentheses now, I have 3 terms that form a trinomial. So I'm going to do the a times c method. A times c is 21. What multiplies to be 21 added or subtracted is negative 4. That's 3 and 7. So I'm going to rewrite this as t squared minus 7t plus 3t minus 21. And then don't forget to bring the 15t down. Now group the first 2 terms together and the last 2 terms together. The GCF of the first 2 is t, so that leaves me with 15t parentheses. Now what's in here? I've got a GCF of t. What's left? T minus 7. GCF of the last 2 is positive 3. What's left? T minus 7. So that factors to be 15t times what's in front of the parentheses, t plus 3, times what the matching parentheses are, t minus 7. Okay, so this problem here requires a little different way of thinking. Alright, first let's focus on this 4x to the 2a. That can be written a little differently. That can be written as 4x to the a, and think about that as being squared. Okay, just the x to the a being squared. That's rewritten as a power to a power, so you multiply those together to give us 2a. So now I've got x to the a that's being squared. Then I've got a regular x to the a. Then I've got minus 3. So this looks more like my general trinomial form. So from here, you do the same thing. Do a times c. So 4 times 3 is 12. What multiplies to be 12, added or subtracted, is negative 4. That's going to be 2 and 6. So I'm going to rewrite this as 4x to the a squared minus 6x to the a plus 2x to the a minus 3. Now, I'm going to group. What's the GCF of the first two? They both share a 2. They both share an x to the a. Now, what is left? That is 2x to the a minus 3. Because remember, the x to the a was squared, which means you had 2 of them, so I could factor 1 out. Now, the second term, the GCF is 1. What's left? 2x to the a minus 3. My parentheses match, which means the grouping was successful. Now this factors to be 2x to the a plus 1 times 2x to the a minus 3. And if you want to, you can distribute that out to actually check your answer. But I'm not going to take the time to do that now. Okay, looking at this problem, I'm looking for a GCF. There does not exist one. Now there are 6 terms in this problem, which means I need to group. I'm going to group 3 terms at a time. Now looking in the first set of parentheses, what is the GCF? It is x to the 4th. Now what's left? X squared minus 2x plus 1. Now, look in the second set of parentheses. It has a GCF of negative 1. What's left? X squared minus 2x plus 1. Now, look, I've got 2 things where the parentheses match, which means this factors as x to the 4th minus 1 times x squared minus 2x plus 1. Now, x to the 4th minus 1 is the difference of perfect squares. So that factors to be x squared plus 1 times x squared minus 1. And then x squared minus 2x plus 1, you can do the a times c method. A times c is 1. What multiplies to be 1, add or subtract is negative 2. That's going to be negative 1 and negative 1. So here, this can be rewritten as x squared minus x plus 1. Now I'm going to group those together. Ooh, it's a bunch of steps. When I do that, that gives me a GCF of x. I've got x minus 1. A GCF of negative 1. That gives me x minus 1. Which once I group that together gives x minus 1 times x minus 1. Alright, and then bringing down these two, that gives me x squared plus 1 times x squared minus 1. And now x squared minus 1 is a difference of perfect squares. So this is x squared plus 1, bringing that down. X squared minus 1 factors to be x plus 1 times x minus 1. And then I'm going to bring down the next 2 x minus 1s. So that is going to be another x minus 1 and another x minus 1, which is simplified to be written as x squared plus 1 times x plus 1 times x minus 1 to the 3rd power. Because that happens 3 times. Okay, here's the second bonus question. Now, this looks very much like our difference of perfect squares problems that we've had before. So we're going to treat it as such. When we do, that's going to give us a plus 2 in the first position in both of our parentheses. And it's going to give us a minus 2 in the second position of both of our parentheses. And then we alternate the signs because there's a difference of perfect squares. But now here's the deal here. Now let's actually take these out of their inner parentheses because they cannot be combined any simpler. So that leaves us with a plus 2 plus a minus 2. And the second one is a plus 2. And make sure you distribute the negative. That's going to be minus a plus 2. Now when I group my like terms together, a and a gives 2a. 2 minus 2 is 0. In the second set of parentheses, a minus a is 0. 2 plus 2 is 4. So this actually factors to be 8a. Interesting. Okay, looking at this problem, the first thing I notice is they all have a c, and they all have a first power with them. So I can factor out a c to the first power of all of these. And when I do that, what is left? Well, it's going to be c to the 2w plus 2c to the w plus 1. Now remember how we had to rewrite that problem on number 21 where it was, it was number 20 where it was 4x to the 2a and we rewrote it as x to the a squared. You're going to have to do the same thing here. So rewriting this is c times c to the w, that's squared, plus 2cw to the w plus 1. Then you got a trinomial. A times c is 1. What multiplies to be 1, added or subtracted is 2. That's 1 and 1. So this is c times c to the w squared plus c to the w plus c to the w plus 1. Now, grouping your terms together, the first two and the last two, I'm left with c. Now, what's the GCF of the first two? They both share a c to the w. You have another c to the w left. And then in the second term, it's just a 1. The second set of parentheses, the GCF is 1. So what's left is c to the w plus 1. Your parentheses match, which is good since we were grouping. So this factors to be c times what was in front of the parentheses, c to the w plus 1, times the matching parentheses, which was c to the w plus 1, which can be stated more simply as c times c to the w plus 1 squared. Okay, here is the last problem of this worksheet. I'm looking for a GCF. There is not one. I notice 27 and 64 are both perfect cubes. X to the 6th, well, a 6 is divisible by 3. And then in the second one, y to the 3t, the 3 is divisible by 3. So I can treat all of this as a sum of perfect cubes. So first, I'm going to identify my a and my b. My a is going to be 3x to the 2s. My b will be 4y to the t. And remember, the exponents, we get those by dividing by 3. That's how we take a cube root of something. And then the numbers is just a normal cube root. Now, plugging into the formula, this is going to be a, which is 3x to the 2s, plus b, 4y to the t, times a squared. So 3 squared is 9, x to the 2s squared. That's a power raised to a power. When you have a power raised to a power, we multiply. So 2s times 2 is 4s. So that's x to the 4s minus ab. 3 times 4 is 12. Then I've got an x to the 2s, a y to the t. And then plus b squared. Okay, 4 squared is 16. Y to the t squared. That's a power raised to a power. We multiply to get 2t. So this is my final answer on the fourth bonus